Well, hi, good morning, and thank you so much for joining me here in my shop. Today is August 1st. Thank God I live in the wonderful country of Canada with the wonderful people that live here with me. Thank God for that. And, okay, that's a great start. What do you think, Bert? What do you think we should do today? So I was in my shop here for about 5 minutes before I turned the camera on because I couldn't remember what I did yesterday. Yeah, I did too much in here. But I remember thinking, I think right at the end, maybe what I should do next, kind of a standard procedure if you like, is get rid of this rectifier here, put in a regular diode. Could that affect the hum? Yeah, maybe. So this is a pretty simple procedure. There's terminals here that can be utilized for the new part. The challenge is just getting the diode in the right direction. And believe it or not, I always find this very challenging. It can only be, one way or the other. Somehow I manage to get it wrong an awful lot of the time. So, but that's what I'm going to do. So I'm going to pick a diode. Let's look at the schematic here. So we can anticipate a fair current flows through here briefly, charging up, in particular, this capacitor. So whatever diode I pick has to be able to sustain that. Now I've augmented these with even more capacitance. So is that really a concern? Probably not. Probably not really a concern. If this resistor wasn't there, maybe. But even then, things would happen so fast. How hot can this get in a matter of just a few fractions of a second? So probably 4004. 4005, something like that. Diode. A 1N 4000. Something like that. Okay, I'm going to pick one. Yes, it's microphone time with Bert. Bert the microphone cat. First, he likes to check this one first, and now he's on his way to check the other microphone. How's it working? Is it going okay? Everything seemed fine? Holy smokes. You're getting a little aggressive there, cat. Yeah. Like that's it. Be more gentle. Hang your head there. You goofy cat. And he's going down. This is more exciting than fixing the radio. Will he knock something down? Will something get smashed? That's the question. Continue on. Getting a bit of a shop tour here. Oop. Where'd he go? He didn't. Hey, come on. Hey. Stop. Come on. Let's go. I got a mouse here. Where'd it go? Here it is. Okay. Got a mouse. I missed the door. I missed the door. I went to throw it out the door. I hit the door frame, so it's just here on the floor. It's going to do the trick, though. Come on. There you go. Now I'm going to do, out the door. Right out. That's good. Right out. Come on. I think he feels tricked. Okay, so I just turned the camera on because the cat was doing goofy stuff, but I'm going through my diodes, trying to find some that are decent for this. So I simply asked the Microsoft's Copilot AI. Well, here, I'll show you what I well, all the words got kind of bundled up in my mouth there. This is what I said. List the ratings for the diode series 1N. And this is the chart it came back with. This is the 1N 4000 series, in fact. And so what I'm interested in is the reverse voltage has to be high enough. So 200 would be high enough, for sure. And forward current's 1 amp. I didn't realize that. It's 1 amp for all these 1N. So 1 amp. That's what I'll remember this from now on. But look at the surge currents, 30 amps. Holy smokes. And forward voltage drop. I guess this is with, oh, it says right there, with the 1 amp flowing. Okay, fine. So 404 or 4004 or above will do it. Okay, 4004 or above. So here we are. This is 4002, 4007, 4005. Something else entirely. These are falling out. 4003. And many, many more diodes. Here's some resistors in here. Fused resistors. And lots of like signal diodes like this. I have lots of diodes. So pick one. Pick one. So we'll do the 4005. Very good. Okay. I think there's a good reason why I'm continually confused about diodes. But look at this. And it has to do with current flow, conventional current flow, and electron current flow, and confusion in what people are saying. But just look at this. This is coming from the AI. It says, my replacement diode, this is what I said, has a bar on one end. Is that the negative end? Yes. The bar on one end of the diode indicates the negative terminal. Okay, negative terminal. Like, look at the schematic. There's the bar. Positive. It has to do with, are they talking about current, like conventional current flow, or are they talking about electron current flow, or what are they talking about? So if you're like me and you're confused about this, and you've been working with diodes for 50 years and you are still confused, you're not alone. There's at least two of us in this world that are continually confused about this. But anyway, I have it installed up here, and we're going to operate this radio with the diode. We're going to check the key voltage and the power supply, probably the voltage on the first capacitor after the diode, and see if it doesn't come to, was it 95? And I can control the input voltage in case it's going high. I can prevent that from happening. How high could it go, though? But first, it's coffee break time here. So I am having a difficult day here, like all Canadians, because of American actions. So we're having a very large yeah, it's a bad day here. It's bad. Okay, let me try and stay focused on what's happening here. Yeah, something like this. Feeling a little dreamy there, are you, Bert? Feeling a little dreamy? Yeah. My God, if it wasn't for this cat and his brother, and the other cat too. Oh my God, with the kinds of pressures and stuff going on in the world, and how frightening everything really is, how uncertain our futures are. Thank God I have something like this, because look at how upset he is. He's terribly upset over the world, are you? Oh my gosh. Today's the day the United States levies a 35% tariff on Canadian products being imported into the States. What's not being said, though, is that if the product is covered under our existing trade agreement, don't do that. Under our existing trade agreement, there's no tariff. So although it looks like he's levying a huge 35% tariff, it's not on an awful lot of stuff. So the actual impact of it, I'm not so sure about it. But symbolically, it's terrible. It's terrible. Are you American? Are you in any way a friend of a Canadian? Or are you our enemy? Are you trying to help us get along in life? Or are you trying to undermine us and steal our stuff and destroy what we have? Is that what you're doing? what your government's doing. Oh my gosh, Cat, you gotta just take it a little easy here. Okay. Yeah. Okay, another piece of video I can't post. I'm having a terrible time concentrating this morning on the work because of external factors. You know, August 1st, and it's Tariff Day from the United States. Okay, don't even talk about it. Let's just focus. So what I want to do is measure the voltage that's developing right at the just beyond this diode. Here's the diode right here. Just beyond the diode, isn't it? Let's take a look at the schematic here. Just beyond the diode. Right. So right here, I figure this is 90 or 95 volts because of going all the way up here and finding 92. Actually, it's 92. So 90 volts. 90 volts. We'll see what we get here. Before, this was low, a little bit low, and therefore everything was low. 90 volts. I don't remember what I actually measured at. So I'm going to put the voltmeter right on that spot so we can watch it as I bring up the supply voltage. Okay, voltmeter right on that spot. Okay. And the clip lead. Should I clip this or just touch it? Let's clip it because I'm going to be potentially turning dials and stuff. We want to go on the output side of this diode right there. Meter on, positive. Looking at 90 volts. So on the meter here, 90 volts would be right about straight up. What would cause me to be concerned? Well, we're gonna bring it up slowly. So, in fact, let me turn it down. Supply voltage should be just right here. Open circuit supply voltage coming from the Bruce nuclear power plant, one of the biggest nuclear plants in the world. 91 volts. That's where we're starting. That's okay. We can do that. I plug this in. It's on. Let's turn it on. Okay. How high will you go? Starting with 90 volts. Everything is set. Okay. Nothing. What happened? How come we got nothing here? What happened? That's not what I wanted to see. Seemed to be the radio was just starting to come on too. So is this some kind of problem with my meter? What problem would I have with my meter? Shouldn't be too worried about this going too high just because I changed the diode. I got a low supply voltage. So just turn it on. Don't be so panicky. If the meter doesn't work, there's something going on with the meter. You can actually see the blue wire from the diode going through the radio and coming down to the capacitor here. All looks good. So yeah, let's try it again. Don't be so nervous. There's the radio. So why are we getting nothing here? So we're running 88 volts. Oh, you know what? I've used the clip lead. I bet you I got a bad clip lead. I bet you this is a bad clip lead. Bad boy. Nope. That's not the problem. Do you see? Oh, there it goes. So we're reading here 92 volts. That's bang on, isn't it? That's bang on the money. But we're at a low supply voltage, so this is going to go much higher as I turn up the supply voltage. And this is the problem with changing a diode like this. You get more than what you bargained for. So this is the best place for me to take the reading. And I don't want to step in front of the meter here. I got too many. You know what? Clip lead up there. Where did that yellow clip lead go? Okay. 90 volts. So it's correct right now. I'm going to find out. This is going to go up to like 110 or something. You know, a better voltage to read would be the start of the heater string. That would be a better voltage to monitor. That's more important. Let's take a look at the start of the heater string here. Schematic, please. Heater string is starting on the other side of this resistor, top of this one, top of this capacitor, pin 7 of the 3V4. Pin 7 might be the best place to go. I don't know where this is. We could measure this voltage. But why don't we start here? Nice 9 volts. Pin 7 of the 3V4. Okay, 3V4. Where do I find you? Just to be sure here. Is I think it's the one back here. Oh, which the 3V4 is tube number 3. V3. Okay, and I saw it. Didn't I see it here? V3, and they're pointing right just behind the black capacitor. That's it there, V3. Oh, okay, I got it. Okay, that's it there. That's V3. So I want to go on pin 7 of V3. Let's pull this off here. Pin 7, that would be, it's a 7-pin tube, so it's the last pin this way. This would be the place. Okay, we're looking for 9 volts here. This is the 15 volt scale. 6 volts. Wow, that's way low. Okay, let's go up. Now we're going to try to raise this to the proper, say 115 volts, where it's 90 volts right now. I don't want to get in front of it. Oops. Okay, so I pulled the my camera cord apart. I stepped on it. Let me just give me a second. I'll reset the camera. Hey, stuff happens. Capture device could not be found. Okay, I gotta stop. I'm gonna have to. It's gotten awfully dark in here. Yeah. Okay, I gotta stop. What a mess. Oh, okay. I think I got everything sorted out there. Don't step on the cord. Oh yes, I was moving the camera so you could see the meter while I reach across here. You can also see this number there, 89. Okay, there we go. So we want this really, ideally, should be at 9 volts. My meter's fairly accurate, so we don't have to worry about that. So we're going to crank up the supply here. It's just a huge batch of wires coming down through here. I guess it's just going to have to stay like that. Okay, There we go. Going up. 90 volts. 100 volts. 106. 110. Okay, we're going to set this at 9 volts. Let's see this. So this is doing this because we've got way more than 120 volts. No, we got 120 volts here. What's going on with this? Somewhere in my massive electrical system here, I have a voltage drop that I can't explain. 120. How'd that get to 120? What happened? Did somebody see something? Let's try again. Anyway, turn the knob too quick. It's doing the same weird thing again. And there's 115. Oh, I see. I drove this up to 9. That's right. To drive this up to 9, this had to be at 120. Okay, that's what happened. So at 115 supply volts, a normal voltage in your outlet, I would think. Maybe 117 today, but this meter's not accurate. It's just kind of a funny thing. So, you know, we're getting close to 9 here. Do I think there's any problem with having a diode in there and operating a radio? No, I don't think so. I think we're much better off. There's another spot I can make another measurement. I can make a 6-volt measurement. Was it 6 volts? Let me just peek at the schematic here briefly. I think it was 6 volts on top of the capacitor I stuck in there. 6.4 volts top of that little capacitor. 6.4 volts. Okay. Grab this. 6.4 volts right here. And we got just under 6. Close. Strikes me that probably the tube voltages are satisfactory throughout the radio now. As long as we operate at the proper voltage there. And even if we go up to 120, if the nuclear plants are working really good, then you're still only getting to 9, which is what it says on the schematic. So I think my concerns about the heaters in terms of voltage, there isn't any concern now. Changing this was a good idea. The radio's still making the same hum or buzz. Okay. I think that's all I'm going to do today. I don't think I'm going to do any more. It's another beautiful day here. It's cool today with hot sunshine. It's fantastic. So I'm going to spend the rest of my day outside. Let me turn this off before I forget. It'll be a bad thing. I'll even unplug this. So not a lot done today, but every day just make a little step forward. Maybe eliminate possible problems. Examine very closely certain circuit areas that become of interest. Sooner or later, we will find what is causing the hum. And I wouldn't be surprised if somehow, yeah, I would be surprised. Don't even say that. Okay, well, thanks a lot for watching, and have a great day. See ya.